record that. So, oh shoot, I gave you the answer. Let's try again. It's right, just grab it. Oh my. Are you? Thank you. Okay, so this one's fairly simple. Because I know my 2's and what I raised to. 2 to what power is 16? 4. It's really simple. Okay, so x would be 4. Okay? But if I said this, there's still a number that 2 raised to what power? It gives me 9. We just don't know that commonly in our head. So, we needed to have a way to solve for x still. Just like we had ways to solve for x in its standard forms, right? Does that make sense? So what we do is what we call a logarithm, which is the inverse of exponential. You pay attention. Here is, once again, our basic form. Y equals b to the x. I'll kick him over, but I ain't bending it down. I'm still in the hurtful areas. Okay. No, my hip really hurt.
It's supposed to snow on Saturday.
Sorry. So, there are times that I want to know what x is when I'll have the y and I'll have the base. Does that make sense? So therefore, what we do is a logarithm. What would be the inverse of this logarithm? It'd be x equals b to the y. Wouldn't that be its inverse? But is that how we like to have our inverses, is solve for x? We like them solve for y. So how we do this right here is going to be the exact same thing as a logarithm. And what it is y equals log base b of x. This and this are the same. And I'm going to tell you right now, if you don't memorize from here to here and here to here, you will fail your test.
Is x the exponent or
X is a, how do I want to say this? This is the base, and this is not an exponent, it's just log base of that number. It's not an exponent. I'll show you how to do it on your calculator in just 1 second. Okay? Sir?
Is the x an exponent?
It is not an exponent.
So
You're
that's
okay.
how you
She's
solve.
She's not laughing at you.
So
I want to
this is-
clarify.
So this is how you solve for x when it's in the exponent form?
Yes, ma'am. So I'm going to show you. It's just, oh, guys, just let me teach just for a minute. Just for a minute. James, go. Never mind. Go, James. Go.
Okay, so is b a subscript then?
B is a subscript.
So b is a subscript and then it's just...
X is just lined up right up with X. I mean with log.
Alright,
Awesome. I love you guys. Okay, so now you might be saying, what the hunky monkey? That's what we call chips and chilies when they get stuck together at my school. You know what I'm talking about?
Yeah.
And we say, hey, look at that hunky monkey. You know, my kids find him, they give him to me. It's great. Can somebody tell me what this answer is?
Is that a 500?
That is a base 5, and I'm going to have you hold off just because you know.
No, I don't know.
How do you do
I'll ask you why that's base 5.
Don't even go to your calculator, guys. This is all in your head. So this is what you're trying to figure out. Okay? Now, there's something this equals. And like I said, looking back here, notice, look. Ooh. Down below. Oops, sorry. Went too far.
I think it was the other page. No.
Oh, it's on page 7.
What?
Page 7 at the top.
Oh.
At the
Okay,
top, yeah.
so notice, if you guys will look here, if I'm at a logarithm, this says this base to this power equals this number.
See that?
This base, look, b, raised to the y equals x. Okay, so b raised to this power equals x. So basically on this problem, what I am asking,
It was on 7.
screw it,
At the bottom.
don't like you anymore. Okay, I'm asking, what is this? So I'm saying here, 5 to what power equals 25?
2.
2.
So it's
5 squared.
Oh, yeah.
So this equals 2. 5 squared is 25. So what this logarithm means, what log means is you say, here's my base, raise it to what power is going to be 25. Okay, you guys see that? It's kind of tricky. So what if I had a flip-flop? What if I have log of 25 of? Log base 25 of 5. Ooh, who said it? Who said it? Nice, James. Woo-hoo! Because 25 raised to the 1/2, which is a square root, correct, is 5. Okay, let me show you to the machine. I'm going to help you out. Okay? Now, is there anybody that does not have a TI-84? If you do not, I will show you in just a second how to do it on yours. Okay, that's the TI-84. Now, some of you guys may not have this function, and if you want this function, I can download it to you after class. Okay? If you were right now, hit the alpha button, which is the green button, and F2 or the window button. Alpha F2. You see what number 5 says? Log base. Go down to that. And hit enter. Now why am I using this button instead of the button on the side? I'll tell you in just 1 second. And now it looks like this. Log, box, box, right?
Parentheses. No one cares. What are the big blocks? No one cares. Well, I care. Sorry. I'll
You have nice shoes, but you apologize to James.
James, I'm so sorry.
Okay. So then obviously I put a 25 and a 5 and it comes out to be 0.5, doesn't it?
Yep.
Does that make sense? Now, for those that have a TI-83, or what do you have? Awesome. So, that doesn't help me. What you need to do is you're going to hit the log button on the side. You see it on the side? On the left-hand side? You're going to go log of 5. And it opens a parenthesis. Obviously, you're going to close the parenthesis. Divided by log of 25. And that's how you're going to have to just roll with it. Okay? If yours does not, if you have a TI-84 and the F2 thing did not work, this is what you need to do until I download it to your machine. I will put it on. It makes it nice. Huh? Not now. It takes a little bit. So after class, if you don't mind. Okay, it's really nice. So coming back here, guys, how does a logarithm help us? 2 to the x equals 9. Remember, 2 to what power is 9? So how can this help me? I'm going to change this from exponential to a logarithm. Can you guys change this to a logarithm for me? Okay, it'd be log base what?
9.
2. You always do your base. Base goes in the base. Scissors in that thing. Right by. Go, 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 go. Stop! Hit them in. What goes here? Is it log base 2 of x equals 9?
No.
Log base 2 in the bucket. 9 equals x. Because remember, how do we flip-flop? And this is important again. 2 to the x equals 9. Now, we can find this answer. Let's just kind of justify this answer previously to getting it. What's 2 to the third? 8, right? What's 2 to the fourth? So obviously my answer's got to be between 3 and 4 because 2 to the third was 8, 2 to the fourth was 16. So this answer should be around a 3. Plug and chug, go. So how would you do this, Scott?
Yeah, I got it.
Log of 9 over log of 2? No. Well, 3 point something, blah, blah, blah. I mean, we'll have a spot to tell you why. 3.2, shouldn't it? Or 3.17?
Yeah.
Is that reasonable?
Yep.
Sounds reasonable, doesn't it? Okay? All right, are we okay so far? Now, yes.
Does it make much of a difference to mine? I got 3.15.
Oh, yes it does. You need to flip flop that row. So you need to go log of 9 to do that. But in just a moment, you won't have to worry about that. Woo! That's a backpack. Okay. How this goes here?
Yeah.
Okay, because remember, when I'm in a logarithm, what does this technically say? 2 to this power equals this number. 2 to that power equals that number. See, these are actually equivalent statements. They mean the same thing. Okay? And that's what you need to understand, is that those are the same thing. That's an important concept. Okay? Now, when we get to logarithms, just understand there's going to be a lot of rules with logarithms. Okay? As we go through them, I'm telling you, logs are very simple. They really are. If you don't understand the rules, though, they become very, yes. Painful. They're like a hemorrhoid. Okay? Not that I've ever had one, because I haven't. I just heard. Just stop. Okay. So here's one that I'm going to ask you guys to do, though, without a calculator. And I wouldn't know this answer. I really wouldn't without, well, I do know how to do it, but I can't just say the answer's 5 or something like that. It's something you got to work for. So it's log base 64 of, log base 64 of 32. That's how we say it. Does anybody know what that is? I still don't know what that is, but I know I can solve for it without using my calculator.
How do you similarity of 6? No, it would be 2.
They have a similarity.
Of 2? 64 squared is 32?
No,
No, because 64 raised to the 1/2 is 8. You were thinking times, right? So sometimes here's what I do, ladies and gentlemen. I just set it equal to x. Or a variable. It doesn't have to be x, it could just be a variable. Okay, and what I say to this is now, without using my calculator, Honcho, tossing. Okay. So now I can say I'm going to go from a logarithm back to exponential. You're going to switch back and forth sometimes. Does that make sense what I'm trying to say? So this is 64 to the x equals 32. Now, here's what you need to do. You ready? What's 64? 8. Okay, awesome. Can I get 32 to be base 8?
Yeah.
No. 2 and 4, 2 and 4, 2 and 2, 2 and 2. How many 2s do I got there? 6. Does everybody see that? 2 to the 6th? 2 times 2 times 2 times 2 times 2 times 2 is 64. So that's 2 to the 6th raised to the x. What do you guys think 32 is? 2 to the 5th. Do we understand how that came about? What did I just do there, ladies and gentlemen? I got these guys to be the same base. Together the same base? Now, what does a power to a power do for us in exponentials? We multiply. So, now, this is 2 to the 6x equals 2 to the 5th. Everybody there? Yes, no? Okay? And then notice, if the bases are the same, and they equal each other, what do the exponents have to do? They equal each other, so 6x equals 5. X is 5.
That's actually a nicer number than what I thought it was going to be.
No? Say again, I'm sorry. You good? Does that make sense, though?
Where did the 2 come?
The 2's, because once again, Pete, see how this is, I don't know what power this is. Yeah. But I do know this is 2 raised to the 5th. But you see how this is 2 raised to that 6x? So therefore, if I have 2 raised to 6x and 2 raised to the 5th, the bases are the same, therefore I know I have to have the same exponents that I just said on the board. Does that answer your question?
Would it be 6 times 5, 6, or would it be 6 to the 5th?
So x is just 5, 6. So, coming back up here,
We're good, never mind.
coming back up here, that means that's what this answer would be. 64 raised to the 5/6 would be 32. Does that make sense? Okay. I gotta skip on to graphing. Okay?
Oh.
So, I'm gonna
have to do with logarithm.
say versus, dude.
Oh.
Answer your question for you. Okay. Oh, that's a put an equal.
Why you put right?
That's a 4, dude.
Oh, okay.
Happy Friday! You hear me squeak on that sucker though? I tell you, American Idol, here I come. I'll get on TV. I'll be like that one guy that made a song. And he still got, huh? Yeah, he got like, he became a millionaire off of his crappy song. It was this other one. Oh.
I still remember.
You got killed?
Yeah, he was mugged forever ago.
Well, he was rich for a little bit.
Was?
Okay, hey, we got time! Time, 10 minutes, people. 11, I'm trying to, sorry, I apologize. Okay. Okay, here we go. -2, -1, 0, 1, and 2. That's what we do, right? Okay. Then we're going to say, oh, that is 1/16, Mr. Roberts. That is 1/4, Mr. Not 14, 4. That is 1, 4, and 16, Mr. Roberts. And we all get the idea of this graph, where it looks like, I don't care exactly how I am, but there it is. We've seen this, so I'm not spending time on this, correct? We did this last time. Are we okay? Okay, notice it approaches what? 0. So what's my domaining really quickly? Parentheses. Good. Range. Yeah, the parentheses help me out all that way. Okay. So that would be my domain and range. But once again, what is a logarithm? An inverse. So notice the inverse of y equals 4 to the x is y equals log base 4 of x. These guys would be considered inverses. You want me to show you how? Because what's the inverse of this guy?
Oh, because one is...
It'd be x equals 4 to the y, right? And notice this and this are the same, right? Okay, so what would we do with inverses? We learned it last time. What does the x and y values do? Switch. So, notice, where does my Fab 5 go? Here. And notice, 4 to the -2 is 1/16. 4 to the -1 is 1/4. 1/4/16. You see how it just...
Do you have to spell that, or
Nope.
just showing?
I'm just showing, I'm explaining. Okay, so here's what the graph would look like. Are we okay there? Can I scroll up?
Wouldn't it just rotate
It goes like this. So 1/16 is very close. Here's what 1/16 here at -2. 1/4 here at 1. 1 you're at 0. 4 you're at 1. 16 you're at 2. So it basically looks like
going over the line, the origin, right?
well, it reflects over the origin. Yeah. And notice, think about it, guys. What value did the x-intercept, the exponential always go through? 0, 1, right? What is this always going to go through? 1, 0, because flip-flop the points.
But
Should
it'll
make
never
sense,
touch
right?
Y, right?
It'll never grab the y-axis, no. Okay, so therefore, let me ask you this question. Notice, I'm never over here. Because remember, here's your equation. Y equals log base 4 of x. Now, your base all depends on what your base was. Does that make sense what I'm saying? Yeah. Okay, so with base 2, obviously, you're going to have 1, 2, 4. Does that make sense? A half, a fourth. Okay? But, watch here. Notice, 4 to what power is ever a negative number? Nothing happens. That's why there's nothing over it, unless you shift it that way. Does that make sense? Because today, that's your new parent function, ladies and gentlemen. And everything else is the exact same when we move it. You see what I'm saying by that? Now look, why is these values over in my y value? Because remember, 4 to this power equals this, right? So that's why I put my Fab 5 in the left column, because 4 to the -2 is a 16th. 4 to the -1 is a 4th. 4 to the 0 is 1. 4 to the first is 4. You guys see what I'm doing? 4 to the second is 16. Okay? So the hard part is, Like for example, I'm going to give you the heart of hearts again. Okay? So if I had -2 log, what base you guys want? Nope, I ain't doing that one. Let's do a half this time. Something a little bit different. Of x minus 3 plus 2 fourths. Once again, this is as hard as hard. But, can I ask you guys, does this thing scare you right here? No, it's the same what we've been doing. And no offense if you haven't got that, you need to come spend some time with me. Does this scare you, the x minus 3? It shouldn't. What does that do to our graph? It shifts it which way? Right 3. What does this do? Up 4, yes. Does that stuff scare you? It shouldn't. What should be new? The parent function, right? So notice, here's what I do. I remember just like I do normally, I start with the parent function. Correct? And so I start here and I say, okay, what am I going to put in here? Here's my x's, here's my y's. Fab 5 in the y. Okay?
And that's because the log is.
Because remember, 1/2 raised to that would be the x value. Does that answer your question?
Yeah, so the log is there.
Yeah. 1/2 raised to the -2 would be -4. Not -4. What the hell is that? 4. Sorry. It's 4. 1/2 to the -2 power is 4. Is everybody good with 4? You want me to show you the work on that? 1/2 to the -2. Remember, if you ever have a negative exponent, you just flip your fraction, right? And 2 squared is 4. Does that make sense where it came from? Yeah. Okay. 1/2 to the -1 is 2. 1/2 to the 0 is, you guys see a pattern here? What's our pattern on this left side? They're getting cut in half because my base is a half, right? So therefore this is going to be a half and this is going to be a fourth. So just talk with me really quick, guys. Couldn't you do this step, and this step all in one? Because we know how to do it now, don't we? So what would that be really quickly? Okay, really quickly, I'm going to move every x value over to the right 3. So that's 7, 5, 4, 3.5, so that's going to be 7/2. I like these. Notice some of you guys struggle going from, just put it here, 3 plus 1/2 is 3.5, and go 6, 5. 7.5. So notice 3 plus a 4, I say 12, plus 1 is 13 fourths. Okay? Does everybody understand where that came from?
So with the function, the inverse function would be 1/2 to the power.
So what this would be is 1/2 to the x equals y would be its inverse, yeah.
Okay. So I was like wondering how could I find that?
Sure. Is that 13 fourths? Yeah, 7/2. Yes, sir.
How did you get that?
Because once again, I added 3 to a half, so that's 3.5. And I go 2 times 3 is 6 plus the y. Okay, can I let you guys finish that part for me though? Removing the, like I'd multiply these guys by -2 and I'd add them up 2, right? So I'd go -2 times -2 is 4. 4 plus 2 is? Oh, 4, sorry. 8. Okay, and then we have 6. I've got 4, right? And then negative, that's just a 2 and that's a 0. So here's what he would look like really quickly. Three and a half. You're at 2, 0, and notice you'll never get close. You won't hit 3 because we shifted that asymptote over at 3 as well, didn't we?
Shouldn't it be -3 and then negative
Oh shoot, yeah, maybe. Sorry, let's do it. What did I do?
It should be -3 and negative. Like 7/2.
Why?
It's -2.
Because if I do a 3 plus a half,
This is not.
that's 3/2, that's 7/2. Are you talking about this right side?
Yeah.
This right side? Okay.
No, the other one. Wait.
Oh, no, never mind. I did something wrong.
Okay. One last thing. We talked about E last time, didn't we?
Yeah, we did.
Okay. The reason why, guys, I showed you on your calculator the other button instead of log. If you ever see a log button without a base, so if I just said log of 10, guess what the answer to that is? 1. And the reason why it's 1 is this is base 10. If you just see a log without a base, it's understood to be base 10. Okay? That's what your left-hand log button is. It's always a base 10. No matter what. Now, remember, E, which we learned last time, correct? Euler's number. Okay, it is such a big thing with exponentials. Obviously, if it's with exponentials, it's part of logarithm. So, if you ever see log base E, that's the button on the other side that says the natural log, or ln. ln is understood to be base E. Okay? I don't know how much of that you're going to be using today, but that is something important. I usually write ln a lot because it's one less letter. Log base E, anything log base E is considered an ln. It's the natural log. They just call it the natural log. Okay,